Hello, everyone. Good evening. Welcome back to the session. I hope I'm audible and the screen visible to all of you. Am I audible and the screen visible to all of you? Could you give me a confirmation, please, before we begin? Yes. Thank you so much for the confirmation. Right. So, second day of our training, data analytics using Microsoft Excel. Yesterday, we had understood what is data analytics. We had spoken about what is Microsoft Excel, how to install it. I had shared the links using which you can install the tool on your machine. Right. If you do not want to install Office 365, you can go ahead and install even the other alternative tool that we have, which is WPS Office. Anything is fine. You can use one of it to practice the concepts. Now, what exactly we did yesterday was we just got familiar with the tool, with the nomenclature, etc. Right? We just I introduced you to the concept that we have a home page where we can choose the blank worksheet to start off with our work. This is the Excel spreadsheet. Excel is basically a spreadsheet application where you will see a lot of columns, A, B, C, D, E. These are columns. And these are rows, 1, 2, 3, 4, 5, etc. are the rows. And every cell here, each block that you see is a cell, and each cell has its own address. So this particular block's address would be G7. Why? Because it is in column G and the row 7. So cell is basically an intersection of the row and the column. Okay. Then we talked about the big five, right? Those 5 basic functions which everybody is supposed to be familiar with. What are they? One is sum, the other is average, the min function, the max function, and the count function. Okay, so this is what we had done yesterday. We will do a quick recap on these things and then we shall proceed. Okay. All right. So here I have some data with me, and this is the employee details, okay, of 360DigiTMG. Now we have some questions that we are supposed to answer. So we have the employee ID, name of the employee, salary, sales amount. So let's say this is the salesperson and the sales that they made. Now we need to get the total salary. So what does it mean? I need to get the summation of the data in the salary column. So as we learned this yesterday, it's pretty simple and straightforward. We can use the sum function of the entire data present in this range. So the range begins at C5, it ends at C10. So the complete range you can see there. This is the total sum of salary. Now, if we have to find out the average of the salary, on an average, what is the salaries that we are giving to our employees? Average of the data in this particular range will give us the value. What is the highest salary being offered? We will use the max function, maximum of the data in this range. And we need to find out what is the minimum salary. So that would be the minimum of the data in this particular range. So maximum is 2000, minimum is 1500, summation is 10,200, and the average is 1700. Now we need to find out the count. So that will be the count function. Okay, count of the number of records that are there in that range. Okay, this is the range that we are looking at, total 6. So far it is all good. Now we have been asked to find out the commission. The commission rate is 2% of sales. Whatever is the sales that the salesperson makes, they will receive 2% commission on that. Okay, so how do we do this? We can use simply multiply. Okay, use the operator, the multiplication sign. So equal to whatever is the data that is present in the sales amount multiplied by 2%. As simple as that, multiplication. Whatever is the sales that they have made, multiplied by 2% would be the commission that they will receive, that the person would receive. So 2% of the sales will be given as the commission, which is 50 here. Now, we need not type in that formula every time. Okay, here also I have to compute 2% of the sales amount. Here also I need to show 2% of this amount. So in that case, we don't have to retype this formula. This is the formula, right? Which we can see on the formula bar. We don't have to retype. Then what to do? Simply, I will go to this corner here. This corner, you can see like a square dot, right? Over there. And when I double click on it, it will copy the formula down. Okay. You can either go there and hold the handle and drag it down. So the same formula will get applied to all those records, or we can simply double click on this handle and the formula will get copied down. Okay, now if you see, this is D2 multiplied by 2%, right? This would be D6 multiplied by 2%. Look at the formula there. D6 multiplied by 2%. Why so? That is because Excel automatically performs something called as relative referencing. Okay, so there's a new term that we are looking at here, new concept, relative referencing. Okay, so the moment I double click here, it copied down the formula, but it is not doing D5 multiplied by 2% everywhere. It has automatically shifted the reference to this cell. Look at that, D6 multiplied by 2%. What about this? It would be D9 multiplied by 2%. So why is the reference to the cell getting updated automatically as we move down? The row number is getting updated automatically as we move down. The cell reference that happens by default in Tableau is called relative referencing. Hence it worked. Okay, so here what happened is the 2% of commission that we are talking about has been hard-coded. In the formula, I have hard-coded 2%. So if someone has to change that, let's say tomorrow we decide to give 3% as the commission, then we'll have to go and edit it over here. So rather than doing like that, we can actually store the commission percentage as a separate value. So let's say commission percent, I would like to store it as a separate value over here in H5. Okay, so it is for now 3%. Or let's keep it as 2%. Initially, I want it to be 2%. This is the commission value, 2%. All right. So I need to refer to this. Rather than hard coding 2%, whatever is the percentage that will be given by the users over here, I will have to refer to this and then accordingly compute the percentage. So what will I do is, rather than doing a multiplication with 2%, I will multiply the sales amount with the value that is present in this particular cell. Okay, we are removing the hard coding part and we are making it reference another value present in another cell and multiply it with that. So the sales amount in D5 will be multiplied with the commission rate, which is given in H5, and the product would be the commission amount, which will come in this particular cell where I've typed in the formula. Okay, I hope you all got this. So now when I click on the enter key, you will see how it has computed 50%. And if I copy it down, how do I copy it down? By doing a double click on this handle. The rest of them are all giving 0. Why are they all giving 0? Let's see. Let's see what Tableau did here. What did it do? What is the formula it has used here? It is doing relative referencing. So when we copy the formula down, when we move down to the 6th row, where the sales amount is 3,000, D6, even the commission rate has relative referencing by default, right? So this also has moved down. Now it is referencing H6, and we do not have any data in H6. What about this? Let's see. Here D8 and it's referencing H8. Okay, which is not correct. There is no value given in H8 and therefore it is 0. The commission itself has become 0. Similarly, if I check here, what happened? D10. So I'm very happy that it is picking up D10. That is what we wanted, right? We have to compute the commission given to this particular salary. So D10 is perfectly fine. But the rate, the percentage commission rate is present in H5, not in H10. Over here, relative reference is fine. With respect to sales amount, it must perform relative referencing, which Excel does by default. But when we are talking about the commission rate, it can't be, it is not supposed to be relative referencing. It has to refer to one particular cell at any given point of time. It must always refer to this particular cell and not move. It is not relative to something. It is an absolute reference that we are supposed to make. Okay, so relative referencing might not help all the time. Sometimes we use something called as absolute referencing. Okay, now what is absolute referencing? I hope you all understood relative referencing, how the reference to the cell will keep changing depending on which row and which column we are in. Whereas absolute referencing is used when you have to lock in a cell. At any given point of time, if I have to refer to that particular cell, no matter what, I have to lock in that cell. Then we use something called as absolute referencing. So how do we do that? H5 is supposed to be made absolute. I need to lock that value in place. So while the mouse pointer is here on H5, you can see that it is on H5, right? Blinking near H5. I will just press down the F4 function key. Okay, F4 function key. So when we press down the F4 function key, what happens is you can notice how before the column reference, there is a $sign, and before the row reference also, there is a $sign that we can see. Means this is referring to this particular cell at any given point of time. Okay, we have logged it in place. This has been logged in place. The reference has been made absolute. Now over here, while this is selected, if I go ahead and press the function key again, you can see the column reference is relative, but the row reference is logged. Only the row has been logged, $sign before the row number. Again, if I do F4, the row is relative, but the column is logged as H. You can see the $sign before H. And if I do F4 again, it just goes back to H5, which will become relative referencing. Now, again, I will go and hit F4. This is how you lock it in place. Okay, so here we need the cell itself to be absolute. Both column and row are locked, referencing to a particular cell. So this is going to help me, and this is called absolute referencing. Okay. When you have logged only column, or if you have logged only row, then that is referred to as mixed referencing. Okay, where we will keep either the row absolute and the column would become relative, or we keep the column absolute and the row will be relative. Okay, if both are absolute, we are locking a cell in place, that is absolute referencing. If both of them are going to be changing, that is relative referencing. If one of it is constant, the other would change, that is mixed referencing. So we will be seeing examples on mixed referencing further into the training, but today we are focusing on relative and absolute. So relative, I hope, is clear. Now let's see how absolute is going to work. As you can notice that we have logged the commission rate by using $H, $5. This. Now, if I copy down that formula by doing a double click on this handle, if I copy it down, you can see. Now look at the formula corresponding to it. D6 multiplied by commission rate H5. If I come here, D9. Okay, the sales amount is relative referencing, so that is changing, whereas the commission rate has been fixed to be absolute referencing. Okay, so that's the difference between relative and absolute referencing, which is a very, very important concept in Excel. Now what we shall do is compute the total salary. So what would be the total salary of the employees? The actual salary plus the commission that they receive the commission that they receive because of their performance. So total salary is equal to, directly we can add, because it's just two numbers, we'll add directly this plus the commission. Okay, so it is C5 plus E5 for this particular employee, Veronica. What about the remaining employees? It has to change. Instead of again writing C6 plus E6, C7 plus E7, what will we do? We will simply double click here, and the autofill feature, magically it just fills in everything. Why? Because it is relative referencing. Okay, so 1800 plus 60, 1860. What is the formula that Excel has used here? C6 plus E6. This is 1500 plus 44, 1544. What's the formula used? C7 plus E7. So on and so forth. Okay, so yeah, so that is about the functions that we learned yesterday, a recap of it, as well as a new concept which we understood just now, that is the difference between relative referencing and absolute referencing. Each of them have their own benefits. Okay. So with this, we will move on to the next section, which is understanding the if statements. Okay. If it comes under logical statements, it is a logical statement. It basically tests a condition, and when the condition is true, it will return certain thing, certain value, and when the condition is false, it will return some other value. So when we simply type in if and we open the bracket, look at the arguments that it is expecting. Look at the syntax. So the logical test. Okay, first argument that we have to give is the logical test, and depending on that test, if it is true, if the test is true, then what value has to be used or what has to be done would be the second argument. And in case the condition or the test that we perform here fails, then what is supposed to be done? If it is false, then what is it that we are supposed to do? Okay, so it is a logical statement. Now there are many other variants in if. We have simple if statement, we can use nested ifs, we can use something called as IFS. Now, if you would like to check whether on the version of Excel that you are using, whether it supports IFS is a relatively new function. So though, if any of you is using very old versions of Excel like 2013 or 2010, 2007, something like that, you might not find it. Anyway, a quick way in which you can check whether or not this feature is available on the version of Excel that you are using is you could simply go to the formulas tool menu, okay, over there, and under logical, it is a logical expression. So just go to logical and you can check from here. I have IFS. Okay, you can check from here whether or not you people have IFS. If it is there, you can use it. If it is not there, also no problem. You can continue using nested ifs. Okay. So what is it? It is a logical statement which tests a certain condition. If the condition is true, it will do something. If the condition is false, it will do something else. We can specify both. What has to be done when the condition is met and what has to be done when the condition is not met. So here today we are going to explore all these logical expressions which are available. Now here is a data source where we have names of employees and their salary as well as their job rating. So let's say this is based on their annual performance. Whenever there is an annual compensation review that happens, depending on the performance of the employees, the organization would give them ratings. Let's say 5 means it is the best, okay, best performance. And 1 means that employee has not performed well at all. The least performing employee is given 1. Okay, how are we rating them? 5 means the best performance and 1 is the lowest performance, the least performance from an employee. Okay. Salary is numerical. Yes, salary is basically currency. Okay, salary is currency. So it has been formatted, as you can notice. if you go back to the home ribbon, right? This is salary, and it has been customized, but even if I just leave it as currency, it will work. But my system, again, by default, it is India, so it's showing the rupee symbol. I formatted it to be compatible with US. The currency symbol I will take is US dollar. Okay, so this is numerical. Now you can notice that we have some numbers, decimal places are here. To remove the decimal places, we can simply click on this icon, which will reduce the decimal places. Okay, this is numerical. Okay, this we can say that it is a number. It contains numerical data. Again, we don't need to give any decimals. Here, this is the accounting or the currency value, and this is general meaning text. Okay, now we are supposed to give bonus to the employees. I said rating 5 means best, and the worst performance or the least performance will given a rating of 1. Okay, now how do we give the bonus? Depending on the salary that they have made. I'm supposed to compute the bonus, but it should be depending on the salary made by the employees. Sorry, not salary made. I have to give them a bonus depending on their job rating. Okay, depending on the job rating. And the final take-home salary would be the salary plus whatever bonus they receive. Together will be their final. So we can do it based on if condition. I will keep showing you step by step how to use if here. If, equal to if. The moment I select it, you can see the function has come, and what is the logical test? It's asking me what is the logical test. I would like to check the value in the job rating column, this one. For each person, the rating is given. So for first employee, it is C2. If it is equal to 5, okay, if the job rating, which is in cell C2, is equal to 5, now, this is my logical test. I want to check whether it is equal to 5. And if it is true, what to do? Let's give a bonus of 5,000. And if it is false, 0. Meaning what? What is the statement going to do? Only when the job rating is 5, only to those employees who obtained a job rating of 5, we are giving them a bonus of 5,000. Everybody else is going to receive 0. No bonus. Now, look at this. There is no value here. Why? Because this over here, this employee's job rating is 1. But I need to do it for all the employees, right? So what to do? Simply, I will double click on the handle here and it will copy the formula down. So only where the job rating is 5, bonus has been given to the employee. Rest of them are not given any bonus at all. That is what it is showing us. Okay. Now, let's say this is not very fair, right? Only if they get job rating 5, they get bonus. Otherwise, no bonus. It's not, doesn't seem very fair. So what I will do is, let us give everybody. Okay, let us give everybody some bonus or the other. Now, how to do that? We can use something called as nested if. It is basically multiple if statements. If inside an if. Okay, if inside an if, nested if. So what will happen? How do we write that? If C2 equal to 5, then I'll give 5,000. That is pretty much clear, which is my true condition. But under the false condition, we will write one more if statement. Okay, because there's another condition to test. I will again say if, again the logical test. What is the logical test? If the value here is equal to 4, then let's give a bonus of 3,000. Okay, comma. What if that is also false? What if the job rating is not 5 and not 4? Then another if. I'm going to check if the job rating that is there in this column is equal to 3. Then let's give them a bonus of 1,500. That is, if it is equal to 3, then what we'll do? We'll give them a bonus of 1,500, comma. What about the false condition? Another if C2, so I'll just copy this, click here. Okay, if C2 is equal to 2. Okay, if it is equal to 2, then I would like to give a bonus of 1,000 rupees, comma. What if that is also false? We'll just make it 0. Means what? If they're getting a job rating of 1, then we are going to give 0 as the bonus. And then one thing that we have to remember here is we have to close as many brackets as we open. It is mandatory to close as many brackets as we open. So here I have opened 1, 2, 3, 4 brackets. So I'll have to close 4. Now when I hit enter, what happened? The formula got applied. What is the job rating of this person? It is 1. Therefore, that person did not receive any bonus. We are not giving any bonus for 1, right? It is 0. Now, if I just copy down this formula, you can notice how it has populated the values. So whoever has a job rating of 4, okay, whoever has a job rating of 4, we said we will give a bonus of 3,000, which happened here. Whoever has a job rating of 5, the bonus is 5,000, which is our first condition. 3, they're getting 1,500. And job rating 2, they're getting 1,000. Okay, over here. And wherever job rating is 1, the last condition, 0. Okay, this is nested if statements, how we can test multiple conditions using the nested if statements. However, this can be a little cumbersome. And here I had just 4 conditions to check for. Imagine if you had a lot of such conditions, then it would get pretty complicated. It would get a little cumbersome. So what other option do we have? In the latest versions of Excel, there is another function called as IFS. Okay. IFS is a slightly more, let's say, refined way of testing multiple conditions. Okay, it is a more concise way of testing multiple conditions. But as I told you, this feature may not be there in very old versions like 2010 and 2007 and all. You have to check. How will you check whether or not it's available? As I told you, you can either go to formulas and check under the logical section whether or not it is present. The other option is just type it equal to IF and just check whether or not it's there. If you find it in the list, it means on the version of Excel that you are using, this function is available. If you do not find it, it means it's not available. If it's not available, then you have to go ahead and keep using the nested if. There is no other workaround there. So now there is one more thing that I would like to change here. In this formula, if you notice the values, be it 5,000 or be it 3,000, be it 1,500, be it 1,000, they are all hard-coded, isn't it? There's a lot of hard coding that has happened over here. Now, rather than hard coding, we will put these bonus values in a separate table, okay, and reference it so that we can avoid the hard coding. Because if I have to change the bonus, let's say when they are getting, when the job rating is 5, the bonus has to be increased to 10,000. Then at every point, I'll have to go and change it, or I'll have to change it here, right? So instead, what I will do is here, I'll bring it here. So there, let's say I have one table where the performance rating and what should be the bonus given to the employees based on their performance is stored separately. Yeah. So that is exactly what we are doing now here, Priyadarshini, right? Yeah, that is exactly what we are doing here. So we're going to create another table, as you can see, where we have the performance rating. And we will refer to these values in our formula rather than hard coding them. How did I bring space between dollar and the numericals? That is the default. Okay, it happens by default. The moment you use the currency as your data type, currency, and if you use US currency, it happens automatically. If you use Indian currency, then you can see the rupee symbol is close to the number, right? But if it is US, then there will be a space between the dollar sign and the value. Yeah. Okay, so I'm going to change my formula now. I'll just delete this whole thing, okay? This is not what I'm going to do. No hard coding anymore. Nested ifs itself, but here by referencing to another column. Okay, so equal to if the value in this particular column is equal to 5, that's my condition. I want to check whether it is 5. If it is 5, if it is true, then I need to give a bonus, which is here. Okay. Now, if it is false, then what to do? And what about this? Should this be relative referencing or should it be absolute referencing? If I leave it as G3, it becomes relative referencing. And next time when I move on to the next row, if I copy the formula down, when it's referencing the second row, this will also move down. So as this reference moves down, this reference also would move down and we might get incorrect output. So for now, I will leave it as relative referencing. Okay, let's leave it as G3 only, comma. And what about if it is false? We have another condition to test. We have another condition to test where we will check whether C2 is equal to 4. If yes, then I'm going to reference this cell to obtain the bonus. And again, another condition to check, if the value in C2 is equal to 3, okay, then I'm going to reference this cell for getting the bonus. Again, if the value in this cell is equal to 2, then I'm going to reference to this particular cell to obtain the bonus. Okay. And here, I will leave it as 0 for everything else. For everything else, let's reference this cell. Okay, for everything else means for 1. If it's not 5, not 4, not 3, not 2, for 1, we are referencing this cell. And remember to close as many brackets that have been opened. 4 brackets have been opened, so 4 of them will get closed. Enter. This person is job rating 1, so obviously the bonus is not there. Now, if I copy this formula down, it will work to some extent, but it does not work beyond that. Right? It went wrong. Why did it go wrong? Because look at the formula now. Look at the formula that Tableau has used for this cell. It is referencing G4, G5, G6, G7. What about the previous case? We started the referencing from G3, right? We were referencing G3 for job role equal to, for performance rating 5. We referenced G3. But when I moved to the next, it is referencing G4. And when I further move down, when I come here, it's referencing G9. We don't have data there. It's referencing these 5 cells in the formula. So because of relative referencing, which is the default referencing, okay, this problem has happened. So what are we supposed to do? I am supposed to use absolute referencing. Whenever the performance rating is 5, I should always refer to this one particular cell. I need to lock that cell in place. Okay, I need to lock that cell in place. So I will go to G3 when C2 equal to 5. If job rating in the job rating column is 5, then I should always reference to this particular cell, lock it in place. How? Just F4 key. So I will go there and press down F4 function key. I'm locking the performance, the bonus cells in place. Okay, I'm going to lock that also. And I'm going to do absolute referencing for this also and lock it in place. Okay, absolute reference. So I hope you all understood the difference between relative reference and absolute reference. Now it will work. Now if I copy down the formula, it would work. Why? Because no matter where I go, to which row I go, I have logged the performance rating reference, the bonus reference has been logged to those particular cells. All right, so we have also seen relative and absolute referencing with another example over here. And here's the formula in case you want to just have a look at it. So we have been looking at simple if, and now we looked at nested if statement. But as you can see, nested if is where you give if inside a if, multiple ifs, which can get a little cumbersome. Now we wanted to avoid that, right? We said, what is an alternative way of writing this in a slightly more concise manner? That is where IFS will come into picture. We will look at IFS now. Okay, now we are going to look at IFS. How do I write IFS? I already have this, but how do I write IFS? Equal to IFS. So IFS, ifs, you can simply call it ifs also. Then look at the syntax. What are the arguments it's expecting? Of course, we have to give the logical test, right? Logical test 1 and value if true 1. So logical test 1 is C2 equal to 5. Then I have to reference this cell and I'm going to use absolute referencing. Okay, comma, look at that. Now after comma, look at what is it asking? Not value if false. With if, the next argument was what should happen if the value is false. But here it's asking for logical test 2. So directly I can type the logical test 2. What is my logical test 2? This, sorry, not this, no. This equal to 4. Then what to do if it is equal to 4? I need to give so and so as the bonus, and I'm going to use absolute referencing for it, comma. Then it's asking logical test 3. What is logical test 3? I have to check whether the job rating is equal to 3. And if that is true, what should I do? I need to give this as the bonus, and it should be made an absolute reference, comma. Next logical test number 4. Logical test 4 is this value equal to 2? If true, then I'll reference this and make it an absolute reference. Then what to do? How do we handle for 1? Okay, how do we handle for 1? What I will do here is not handle it for now. Let me just close it. Okay, let me just close it, and I have an error for 1. Because I have not applied anything for 1, I'll copy down the formula. Rest of the places it's working fine. Okay, the rest of the places it is working fine. Okay, but wherever I had rating of 1 for which I did not handle in my formula, it's not able to do anything. It's saying you have not told me what to do, and it's just giving me an error. What is the error that I'm getting here? Not applicable or not available. NA means something that is not available. Okay, now how do we handle this? There is one very interesting way of handling it in this particular scenario. For 1, I have to do something. So how I can give it is, I will give an argument true, comma, 0. Now, how does this work? How does this work? What is true that I have given at the end of that if statement, and how does it work? Let's apply it first. You see, 0. It's not NA anymore, it is 0. And if I copy down this formula, you see zeros. I have handled the NA error. How did I handle, and what is happening over here? So this is the test, right? Is C2 equal to 5? If it is equal to 5, the condition would become true. Otherwise, the condition is false. So if I double click on this, okay, this particular one, let me just calculate it. You can either hold down F9 function key. It is showing us what the value of the test condition, or we could simply click on this calculate now. So is this condition true or not? C2 equal to 5. Is it true or not? Let us calculate. It is a false condition. Okay. C2 equal to 4. Is that true? Let us calculate. That is also false. So basically, these tests are giving us true or false, right? C2 equal to 3. Let's see. What is that going to result in? False, because this is 1, right? It is false. C2 equal to 2. What is it going to return? Let's calculate. False. It is also giving me false. So how does this formula essentially work? How does this formula, the IFS formula, work is, whenever the first true condition is met, whatever has to be done based on the, whenever true condition is met, it will go ahead and do whatever is supposed to be done for true condition. And that's it. It ends over there. All right. So only when this first condition is false, it goes to the next condition and it will check. This is also false, then it checks for the third condition. If this is also false, it goes to the fourth condition. So it will keep checking the conditions, the tests that we have written. These are called logical tests, right? It will keep on checking the logical tests until it encounters true. Okay, the moment it encounters true, which is the test condition, if the test condition becomes true, then it will return so and so value. So when all of these conditions are false, I'm saying by default it is true. Rather than writing C2 is equal to 1, which would have become true, right? If I had written C2 equal to 1, it would have become true and then it would have given 0. But instead of writing that, it's like catch-all. Okay, let's say there are multiple conditions to test. For like for 5, you have to do something. For 4, you have to do something. For 3, you have to do something. And for everything else, you have to do something. For everything else. Getting it? Here are everything else is just 1. But what you have a lot of conditions. For everything else, what to do? We are just going to give 0. Understood? I hope you all understood. This can be a little tricky, but I hope you all understood. So let's check for this particular row, okay? This particular member. So what is the formula for this one? Look at that here. C3, this is the test condition. C3 equal to 5. Is it true? If I calculate, no, it's false. So if this is false, what will Excel do? It will move on and test the next condition. Logical test 2. I'll press F9. This turned out to be true. So because logical test 2 has become true, it will just perform whatever has to be performed over there. Value if true. What is the value we are supposed to take if it is true? The one that is there in G4. The one that is there in G4 is taken. Okay, over here, you will see that when I click on enter, under 4, 2500 would come. It does not go and test the remaining conditions. So when all the conditions that have been specified, all the tests result in a false value, we are hard coding true for everything else and giving 0. All right, I hope the purpose of true and 0 and how it is handling everything else. It's like catch-all. For one scenario, do this. For the second scenario, do this. And for all the other scenarios, catch all the other scenarios using this true condition and give 0. That is the kind of thing which has happened here. Okay, now by giving an absolute reference, by providing the bonuses in a separate table, what is the advantage that we are going to get? Suppose the bonus changes. Let's say tomorrow I decide to give 5,000. Okay, suppose the bonus changes. Then I just have to change it over here, nowhere else. It will get automatically applied everywhere else, you see. Suppose now suddenly we decided to give bonus even to those employees who are getting a performance rating of 1. They will get 100 rupees. Then what will happen? Everywhere else it gets reflected. Okay. But here also I'll have to change because here I didn't do it based on a test. I did it based on the true condition. In this case, 100. And let me copy that formula down. Okay. Is IFS clear to everybody? No, it's not as simple as simply the number of brackets that you open and close. Rohini, just observe this particular formula. Every time we are giving an if and putting the condition if, isn't it? This is what happens if you're using nested ifs. If inside an if, then inside that another if, then inside that another if. This is an if inside another if, not a separate if by itself, independent one. No. These are nested. So innermost one will be computed first. This also takes more time because the innermost if condition is tested first. Then this one will be looked for. Then this one. Like that, it is basically checking a lot of things. Nested ifs. Okay. whatever sequence it goes. But with IFS, let me send you this formula in the chat. And now compare it with this formula that we have written. Okay. So when there are a lot of conditions, IFS would be better. When there is only, there are a few conditions, you can go with nested ifs. If there is only one condition, then you can go with a simple if. So true option that we give under IFS, it is a beautiful way to catch the default value. Very well, you can catch the default value with that true option that is available. Okay. So now let's move on to a few more if statements. Okay, so this is my data. Let's say there is some data wherein there are different types of products like coffee, tea, herbal tea, and espresso being sold in different states. So 4 to 5 states of data I have here. And this is the statistics, let's say, of 2013 and 2012. Okay, for 2 different years, I have the statistics of the sales of a variety of products, tea, coffee, herbal tea, and espresso across different states. And in each of these states, there is a target that is given to them, which is called as budget sales, or simply we can rename it. I'll just call it target sales. Okay, it will be easier that way. Okay, let's say this is the target sales. And the actual sales also is there. This is the, let's say, actual sales. Okay. Now, if you look at difference, I have obtained the difference between the actual sales and the target sales. Look at difference. It is basically this. I'm taking the data in E2 and subtracting D2. Okay, I'm getting the difference by subtracting these two. So if the difference is negative, what would it mean? If the difference is negative, it would mean that the actual sales is less than the target sales, isn't it? We could not reach the target. The target was higher and actual made is lesser. Therefore, the difference is negative. And wherever the difference is positive, it means the actual sales is better than the target that was given. Okay. We are saying that if the difference is positive, it means that the actual sales is better than the target. We have gone beyond the expectation. That particular state in the sales of that particular product has gone above the expectation. It has gone beyond the target and overperformed. It performed well. Okay. Now, okay, there is one question. Yes, the IFS statement that we had talked about, right? You can reference even a cell over there. Okay, Swarupasya. You can definitely reference a cell even without hard coding the value. So one moment. I'll show you. Okay. I think I'll have to just type it in. Okay, you can simply lock it in place over there and get it. And suppose I update this number now from 0, suppose I change it and give a bonus of 100. You see how it got updated in the formula? So rather than hard coding a value over here, you can definitely go ahead and reference the cell. Okay, make it an absolute reference so that whenever the value here changes, accordingly it will get updated. Let's say we increase this to 5,000. You see how it gets reflected here. Suppose I increase this to 1,000. It gets reflected. Suppose I increase this to 5. Okay, that is the idea. Basically, that is why we are referencing a table. Okay, before we proceed to the next set of topics or things that we are going to cover, is this clear? Whatever we have discussed about simple if, nested if, and IFS. So let's understand this data. We are just looking at the various products that are sold across different states, across 2 different years. We have the goal and we have the actual sales. We have, and difference is computed here. It is not a member. It has been computed. If the difference is positive, it means that state is doing well. It has achieved the target. If the difference is negative, it means it could not reach the target. Now we are familiar with the max function and the min function. Max and min are clear to us, isn't it? It gets the maximum value. It gives the minimum value. Suppose if I just type in max of the data present in this particular column, it will give me what is the maximum sales. It is 17,505 over here. Over here, that is the maximum sales. Okay. So if I want to get the minimum, I'll just have to replace max with min, and it will give me the minimum sale value. Minimum value in that column, which is 1,129. All right. So max and min present in a column, we can get it. But how do we get it based on certain conditions? That is what I'm doing here. That is what I'm going to show you over here. So I need to find out what is the maximum sales, not for the overall data, not for the entire data, but I need the maximum sales made by the state of Colorado in the year 2013. Okay, in the year of 2013, what is the maximum sales that this particular state made? Then how to give that condition? Equal to, we have a function called max IFS. Now again, this function may not be available on older versions. It is there in relatively newer versions. Now, what is it that we have to mention? What are the arguments that it expects? Okay, what are the arguments that it expects? First, max range. We are asking it to look for the maximum value. But in where? From where is it supposed to choose the maximum? That range. I want it to choose the maximum value of sales present in the actual sales column. So I'm going to select it, do a command shift down, control shift down for the whole thing to be selected. So I want it to identify the maximum value present in this column. E2 to E49 is my data from that data, comma. Okay, we need the maximum value in that range, but based on what condition? Right, we want it based on certain conditions. So when I hit comma, you see what is the next argument? Criteria range 1. Okay, I need to look for something. In which range am I supposed to look for it? There is a condition that you will mention, and I'm supposed to look for that condition somewhere. Where am I supposed to look for it? In which range am I supposed to search for the true condition? So that range, let's say, is the year. Okay, look at the year column. Look at the year column. That is my range 1. And what is the criteria? It is supposed to be 2013. So I'm going to select 2013. Of course, we could have typed 2013, but we are referencing to a cell so that we can change the value in the cell and accordingly we get the maximum value. Comma. Now it's asking, what is the next criteria range? Okay, now I want Excel to look at the data in the state column. Okay, look at the data in the state column and then look for that particular state which is mentioned here and get the maximum. Just look at the formula. What is it trying to tell? Let me delete everything else. It gave us, but let me just remove everything else. We will continue with this data set tomorrow also. So look at what has happened. I'm telling, give me the maximum value. From where should I get you the maximum value? From the data that is present in this range, in this column, actual sales. Okay. And the maximum value has to be obtained from the max range based on what all conditions. I have two conditions. What is my first condition? I need the maximum from the year 2013. Second condition is for the state Colorado. Okay. So where is year present? That is the next range where Tableau has to look for. It has to look for 2013 in this range. So that is my criteria range 1. And what is it looking for? For whatever year I specify in H3. What is the second criteria range? Whichever column has the names of the states. And what am I asking it to look for? I'm looking for whatever state is mentioned in I3. If I do this and apply, you can see it has obtained the maximum sales for Colorado from 2013, which happens to be 8,446. I hope you'll understood. Okay, now what if my condition changes? I want to find out what is the maximum sales of Florida. Florida, it is bringing from 2013, the maximum is 6,107. But I want to know what is the maximum sales of Florida in 2012. It changed. It is 5,867. So in 2012, if we look at Florida, the maximum is 5,867. This one here, 5,867. Okay. So by not hard coding the values in the formula, what did we achieve? We are referencing a particular cell to apply conditions. Whatever year I want, I can mention here. Whatever state I might want, I'll mention here. It will look in the year range for that particular year, in the state range for that particular state, and it is getting the maximum value. Here we have given two conditions. Like that, you can keep giving as many conditions as you want. Okay, I hope you all understood this formula. So we shall wind up here. Today, our focus was mainly to understand the if conditions. We shall continue with the same thing tomorrow also. We have understood the difference between relative referencing and absolute referencing. We understood simple if statement, nested if statements, IFS statement. And one small example I have given you on using the max ifs. So tomorrow when we meet, we will look at min ifs, we will look at count ifs, we will look at sum ifs. Okay. After that, we shall look at conditional formatting. So that would be the agenda for tomorrow. Yeah, that's it from my side. You can let me know if there are any questions. Yeah. About sharing the data sets, yes, please do join this WhatsApp group. I will post all the data sets in the WhatsApp group. Are you all there in the WhatsApp group? Whoever is not there, please join. And I will be sharing the data sets through the WhatsApp group. And if you have not yet subscribed to the channel, please do subscribe. If you would like to refer back to this recording, here's the link to the recording. Wait, I'll resend the WhatsApp group link. Yeah, Avinash, today Tableau will be from 8 to 10, correct? Yeah, Vijay Kumar, we will do a recap on max if condition tomorrow. Okay, in our recap, we will cover max if again, post which we will look at min if, we will look at count if and sum ifs. So that will clarify all the doubts that you have. So whoever is not there in the WhatsApp group, you might want to join it. And whoever has not yet subscribed, please do subscribe to the channel. You can watch today's recording, day 2's recording in this link. Okay, which I have sent you all. So you can use this link to refer back to today's recording. Do we get a certificate? I don't think there is any certificate being provided. However, I will confirm it tomorrow. Okay. Anything else, any of you? Otherwise, we can end the meeting here and see you tomorrow. No, Karthik, Tableau is a paid session. That is a paid session for people who have enrolled for Tableau. Okay. All right. Thank you all so much. Then we'll end the meeting here. Thank you. Bye-bye.